Chapter 6 is mostly about patterns, functions, they're called, but a lot of patterns and a lot of putting stuff in and getting stuff out. That's chapter 6. This is our warm up. And it's asking me to find the missing value in the table. So there's got to be something that we're doing from the left side to get to the right side that makes us able to figure out what the pattern or what these things are going to be. So if X is 5 and Y is 10, I'm going from 5 to 10. How can I go from 5 to 10? I can add 5. I can times 2. I don't know. We'll see. I go from 7 to 14. I go from 10 to 20. So my pattern is not add 5. My pattern is to get from the left to the right, I times 2. So in order to get from 40 to Y, I times 2, and that gives me 80. That's supposed to be an 80. While I'm doing the middle one, I want you guys to put in the chat what you think that one's going to be. And so hopefully before I get there, somebody puts it out for me. I have 0.5. That goes to 1. Okay. I have 1.5. That goes to 2. Okay. And I have 3. That goes to 3.5. So am I multiplying here? No, it doesn't look like it. It looks like I'm adding a half. It looks like I'm adding 0.5. And so if I take my X value, 9.5, and add 0.5 to it, I get straight 10, baby. That's what I am, a 10. That's what my mom says. I'm going from 15 to 5. All right, so I'm getting smaller so I could subtract 10. But that's not what I'm doing here, and that's not what I'm doing here. So if I get from 15 to 5, 30 to 10, 45 to 15, I'm doing one thing, and I'm dividing by 3. So 60 divided by 3 is 20. 20. I'm closing a few of my tabs because things are running a bit slow today. That would be why. Let me just close out of that. Okay, I think we're good. All right. I will be able to determine if a relation is a function. What's a relation? Well, let me put it in terms that you teens would understand. Say it's not a pandemic and you're sitting in a class and you see Bay walk through the room. Or somebody you wish to be Bay. And you're like, oh man, that person of the gender that I'm attracted to is very attractive. And I would like to date him or her. And so you decide to, maybe have a conversation with them. Maybe you chat back and forth. Maybe you trade funny memes. Maybe you, I don't know what kids do these days. Probably say, hey, what's that on your shirt? And go boop. And then that person's in love with you. I'm not sure. But you get into this relationship with them. And a relationship involves a pair. So a relation is a set of ordered pairs. What's an ordered pair? Well, an ordered pair is an XY, a point, of course. So a relation is a bunch of them. So 2, 3 is an ordered pair. -1, 5 is an ordered pair. 0, 3 is an ordered pair. And because I'm running out of room, 2, 8 is an ordered pair. So that's a relation. A relation is just a list of points. Okay, and there's many ways that we can organize that relation, and one of the ways that we can organize a relation, a set of points, mapping diagram. So let's check it out.
All right, time to make a mapping diagram. A mapping diagram is when you take a set of points and you fill them into bubbles with a domain and a range. I will show that in 1 second. So my points are -4, 6, 1, -3, 0, -4, 1, 0. Your domain are going to be your x values in order. So I have a -4, which is my smallest number. I have a 1, a 0, and a 1. So I'm going to write out 0 and 1, and I'm not going to write out the 1 twice. My range are the y values, 6, -3, -4, and 0. So the smallest of those is -4, then -3, then 0, then 6. -4 goes to 6, so draw an arrow. 1 goes to -3, 0 goes to -4, and 1 also goes to 0. And that's my mapping diagram.
So I went very fast there. I went very fast. So let's slow it down. And at the very least, if you don't understand, you know that there's a video on the internet where I do it in 1 minute. So this is what we do. We have what's called a domain and a range. The domain are going to be your x values, your input. Okay, the domain's going to be your x values, also known as your input. So I'm going to make a bubble on the left, and I'm going to call that D for domain. And I'm going to make a bubble on the right, and I'm going to call that R. Actually, let me change colors here just so I can be really specific. I'm going to call that R for range. D stands for domain, R stands for range. My domain, also known as my input, are the x values. So I have a point here. I actually have 5 of them. -4, 3 is a point. 7, -3 is a point. 0, 4 is a point. What I'm going to do is I'm going to look at all of these points and pick out my x values, and the x values are going to be my domain. The x values are my domain. And then what I do is I write out these numbers in order, okay, from least to greatest. So I have -4, and I have 7, and I have 0, and I have 1, and I have 2. So my goal is to make sure that I put the smallest number up here. So let me see. The smallest number out of -4, 7, 0, 1, and 2 is -4. Boop, 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 boop. Then what? I have I have 7, and I have 0, and I have 1, and I have 2. Well, then the next one's going to be 0, and then 1, and then 2, and then 7. That's me putting them in order from least to greatest. That's me putting them in order from least to greatest. Now I have to do the same thing for the range. The range is the y values. So I'm going to underline those in green. So I have 3, and I have -3, and I have 4, and I have -3 again, and I have 1. And what I do is I have, one more time, 3, -3, 4, -3 again, and then I have 1. My smallest number out of these green underlines is -3. I have -3 twice. I'm only going to write it down one time. One time. And then what's the next number? So I have 1, and I have 4, and I have 3. So the next one is 1, and then 3, and then 4. So what I did is I wrote out my numbers in order. In order. Now this is what I do. If you saw in the video, I put all these arrows going all over the place. What does that mean? Well, if I have a point -4 going to 3, and my point -4 goes to 3, I'm going to put an arrow from -4 to 3. Like that. And then 0 goes to 4. 0 goes to 4. How do I know that? Because up here, 0 goes to 4. I don't know why I'm going out of order. 7 goes to -3. So 7 goes to -3. 0 went to 4. I did that already. 1 goes to -3. So 1 goes to -3. So, yep, I have 2 different arrows going to the same number. That's fine. And 2 goes to 1. So it looks kind of messy. But again, what I have is I have on the left side, I have my domain, which is the x values. On the right side, I have my range, which is the y values. And depending on the point, I say -4 goes to 3, 7 goes to -3, 0 goes to 4, 1 goes to -3, 2 goes to 1. So the most common questions that I get about these are, how do I know the numbers that I put in? Make sure they're in order, and your domain are your x values, and your range are your y values. How do I know the arrows? Well, it always goes from the left to the right. And the arrows, the number that you go from one number to the next number is dependent on the point. So since 0 goes to 4 on the point up here, then 0 goes to 4 in the bubbles down there. Let's do it again. Let's do it again. Can't wait to be on. I put an audition for The Masked Singer, and I'm thinking I have a chance. I'm assuming it's called The Masked Singer because they don't want to see my face, which makes no sense. I'm so good looking. Why wouldn't they? Oh. All right. So what I did is I made a bubble and I called it D for domain. Your book likes to call it input. Same thing. Domain, input. It's all good, right? It's all good. And in my domain, I underline my x values. So I have -2, and I have regular 3, and I have -9, and I have -9 again. So now I need to put these in order. And any number that repeats, I only write it once. So the smallest number here was -9. Remember, the larger the negative digit, the smaller the number. If I owe $9, that's a bigger problem than if I owe $2. So -9 comes first because it's smaller. And then -2, boop, boop, and then 3, boop. Where did I get those numbers again? They were the x values. I underlined them in blue, -2, 3, -9, and -9. -9 was the smallest, and I know there's 2 of them, but I'm only going to write it out once. And then there was -2, and then there was 3. Now I draw out my other bubble. I guess when students tell me that I'm drawing, this is what they must mean. Right, guys? Oh, boy. I can't wait for January 11th. So I'm underlining 4. I'm underlining -2. I'm underlining 5. And I'm underlining -2 again. So I repeat numbers again. So my numbers are 4, -2, 5, and -2. The smallest number here is -2. I only write it out once. I don't care if there's 2 of them. I only write it out once. -2. What else? What's next? So -2, and then I have 4, and then I have 5. So 4 comes next, and then 5. Now I need to draw my arrows. So going left to right, -2 goes to 4. -2 goes to 4. -2 goes to 4. -2 goes to 4. 3 goes to -2. 3 goes to -2. -9 goes to 5. -9 goes to 5. And -9 goes to -2. Oh, it almost looks like the Off-White logo, almost, because of the X. Breathe it in. Take it in. Look at it and say, ooh, that's interesting. Mapping diagrams. That's what fun. Boy. Make a mapping diagram. I could do this. This is what I'm going to do first. Before I make a mapping diagram, I'm going to look at the points that I have and write out the points that I have. So it looks like the points that I have here are -3, -3. So my one point is -3, -3. I have another point. It's -1, -1. Okay. I have another point that's 1, 1. Okay. And I have another point that's 3, 3. Okay. Okay. Let me see. That's my domain, and that's my domain, and that's my domain, and that's my domain. And I'm going to make a domain. And I write it out in order. Oh, God is good. It's already in order. -3, -1, 1, 3. Dope. And then I have -3 for a range. And then I have -1 for a range. And I have 1 for range. And I have 3 for range. And if you're wondering, sir, those are the same exact numbers. They sure are. Way to be creative. Problem I stole from the internet. So I have -3 is the smallest. They're in order, just like the last one. -1, 1, and 3. Now I connect the one to the other. -3 goes to -3. -1 goes to -1. 1 goes to 1. 3 goes to 3. And if you're like, that's a lot different looking than the last ones, it sure is. The reason why this one looks so nice and the other ones were like all over the place, arrows everywhere, is these numbers are exactly the same. They're already in order. There's nothing tricky about this at all. This is how many mapping diagrams look. They look nice. It's just that I try to give you ugly ones too because, hey, just like people, there's a lot of ugly problems, and we have to deal with them. Another mapping diagram. OMG, 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 you guys, OMG. That means oh my goodness, in case you don't know what OMG means. Whew, 6 of them. So I have, oh, look, they go by 2s also. Barf. Barf City. So this point is -4, +8. So let me write that out up here. -4, +8. And then I have -2, +8 again. That's supposed to say -2. And then I have 0, +8 again with the 8s. And then I have 2, 8. And then I have 4, 8. And then I have 6, 8. And then I have 8, 8. So those are all my points, all 7 of them. I think I said 6 of them, but there's actually 7 points. Well, the rules don't change. Whether I have 3 points or 7 points, I'm going to write a bubble on the left and put a D for domain. And I'm going to put a bubble on the right and put an R there for range. Let's find my domain. I have -4, and I have -2, and I have 0, and I have 2, and I have 4, and I have 6, and I have 8, and they're all ready in order. God is good. I have -4, and I have -2, and I have 0, and I have 2, and I have 4, and I have 6, and I have 8. What's my range? Pretty easy. 8, 8, 8 is great. You can write it this way. You can write it that way. 8, 8, 8 is great. It makes me say, hooray. In my range, I put an 8. And I know I have 7 of them. I'm only going to write it out one time. And now I need my arrows. -4 goes to 8. -4 goes to 8. -2 goes to 8. So I know what's going to happen. All of these guys are just going to go right to 8. Easy. Easy. Now what? Now what, you ask? Well, the title of this lesson was Relations and Functions. What haven't we talked about yet? Functions. So I actually want to go here before watching the video. We'll watch the video. So I have a relation is a function. Now this is going to sound awful. The definition is awful. A relation is a function if every x value goes to exactly one y value. That's an awful, awful, awful sounding definition. What does that mean? I give you a bunch of points, or we draw two bubbles and we have arrows going everywhere. It's a mess. So what the heck is every x value goes to exactly one y value? What does that mean? That means x, if I give you a bunch of points, x can only be used once. So I give you a bunch of points. And I look at all my x values. I don't care about my y values. I can care less about my y values. Who cares about my y values? I don't care about my y values. No one cares about them. I look at all my x values. And if every x is only used once, I have a function. If there's an x value used more than once, I don't have a function. So what does that look like? Let's go to that video now. I'll mute myself so there's no echo.
List the ordered pairs in the mapping diagram. I have a mapping diagram right here. And in this mapping diagram, I have 4 members of the domain, 3 members of the range, and I'm
That's the wrong video. Oh, well. All right. Well, let's understand it again. Let's go back and try to understand it again. A function is a function if x is only used once. If x is only used once. If x is only used once. What are my x values? They're the first numbers in each point. You're an x value. You're an x. X, X, X. Oh, rest in peace. Rest in peace, March 18th, 2018. Rest in peace. XXX Tentacion, of course. So I have all of these points, and my job is to determine if I have a function or not a function. A function is a function if each x is only used once. So I have -4. Is the x value -4 used again? No. Is 7 used again as an x? No. Is 0 used again as an x? No. Is 1 used again as an x? Now, before you say yes, this one over here is a y. The x's can't repeat. I don't care if x is 1 and y is 1. I don't care. Is 1 used again as an x value? No. So I'm looking at all my underlines. And if all of my underlined numbers are different, I have a function. If all the numbers that are x's that I underlined are used only once, then I have a function. Problem 6. I have -2, 4. I have 3, -2. I have -9, 5. I have -9, -2. Is each relation a function? I have to underline my x's. Boop, 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 boop. And do any of those underlines repeat? Let me see. Is -2 used as a x again? No, it's used as a y, but I don't care about my y's. Is 3 used again? No. Is -9 used again? Yes. See how this -9 x is used again as an x value? If my x values repeat, it's not a function. No. If my x values repeat, it's not a function. If my x values don't repeat, it is a function. X values can't repeat. And the real life term is this. Like, the x value is like an input. Like, if I were to go to a soda machine and put in $1, okay, and if by putting in $1, I get out 2 different things, that's great, but that's not supposed to happen. My machine is not functioning correctly. Okay, so it'll make more sense when I do the mapping diagram stuff, which is what the video that I meant to show you earlier. Let me mute.
Function or not a function, which mapping diagrams are functions? What you're looking for is if an x value or an input value is mapped to 2 different things. In other words, is an x value used twice? And if it is, it's not a function. So see this 2? This 2 splits up and goes to 2 outputs, which means this is not a function. The middle one, I have 10 going to 15, 20 to 45, 30 to 25, 40 to 35. Every x value has its own y value. So this is a function because you don't see a member of the output repeating. Similarly, the next one, you might think that this is not because y over here is used twice, but I don't care how many times the output's used. I only care if every input is used once, and according to this, it is. So that guy right there is also a function.
Ooh, like and subscribe. All right, so let's take a look at this. Now, sometimes they're called inputs, sometimes they're called domains. It's the same thing. Okay, it's the same thing. If I were to go to an arcade and I was given tokens, and every token could mean how many times I can play a game or whatever, it would make sense that if I put in 1 token, I get 3 games. If I put in 2 tokens, I would get 6 games. If I put in 3 tokens, I would get 9 games. It's not going to be like, oh, if you put in 1 token, you're going to get 3 games and 6 games and 9 games. That doesn't make sense. The best way to view this is I want you to pretend that you're playing darts. You know what darts is. I take a dart and I throw it at the Captain America thing behind me, and if the dart sticks, then I win. If I were to have 4 darts, and if I were to label them, if I were to write on my darts 1, 2, 3, and 4, and if I were to throw a dart at a target, and the first dart that I throw hits a 3, that's fine. If it hits a 6, great. If it hits a 9, awesome. If it hits a 12, fine. This makes sense. Is this a function? Yes. And the most obvious reason why, and the most understandable reason why, is because every x value, and remember, the input is an x value, every x value only goes to 1 y value. Every x value, every input, every domain is only used once. Look at 8. If I were playing darts, and if I had a dartboard, if I had a bunch of targets written on my wall back here, and on one target I called it 1, and let's just say I was closing my eyes, I'm making my own dart game. And so I put pieces of paper on my wall back here that say 1, 0, -2, -3. And if I take a dart labeled 0 and throw it backwards, and I look at what I hit, and I hit the target that says 0, I get 0 points. Great, yippee, I get 0 points. This is where it gets weird. I have a dart labeled 2. According to this, I throw the dart behind me. A magician comes up, and a wizard comes up and hits the dart and says, I bless you. I bless you with the ability to split in half. Pew! And he takes his wizard wand, and he goes, pew, and my dart splits in half and hits two different targets. Ba-bum, ba-bum. I watch movies. Last time I checked, wizards aren't real. And I'm sorry if this is the first time you're hearing that. They're not. Magic isn't real. The only magic that I care about is God. And if you ever want to talk to about him, kids, you just let me know. But is this a function? No! This is not a function because I have an X value splitting up. Once you see the X value split up, you say no. 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 Is this a function? 2 goes to 6, 4 goes to 3, 6 goes to 0, and 8 goes to -3. Everything has its own thing. Is this a function? Yes, because every X value goes to exactly one Y value. X does not split up. Look at 10. 10 fails not once, but twice, because I have an input that splits up and goes to two different outputs. I have an X value that has two different Y values. And it happens again. So no, it's not a function. Function no. And that's that. Describe and correct the error in determining whether the relation is a function. Each output is paired with exactly one input, so it's exactly the no. It's no. See how it's splitting off into 4 different things? No. 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 This is me trying to write fast on my board, and that's how bad it is. That's not a function because 4 is splitting off. They have it backwards. Shame on them.